Hey, my name is Ronnie Chowdhury and welcome back to my modern high-performance C++ tutorials. Today I'm going to discuss something I saw at a client recently. The pretty well-known factory pattern that's used in pretty much any language, whether it's C++ or Java or even Python. I was doing some performance testing on the code and it struck me that this classic pattern has been used in a particular way and coded in a particular way for a very long time. And I think could be improved upon in both expressiveness and performance and static type safety if you wanted to, using the latest C++ features. But before I start, I wanted to just let you know you can follow me on Twitter or even contact me via LinkedIn for some C++ consultancy, software architecture or training, especially in the quantitative finance space. And also remember, if you want to see more of these videos, please like and subscribe below. Let's start with the standard implementation of this pattern. We've got a price base class with a stock and option price deriving from it. Pretty normal. We can put them all in a vector as well using these price pointers. And we have this pure virtual method called price_me. Immediately you can see a potential bug with these price pointers never being deleted. So we can fix that at least by using a unique pointer. There's no factory pattern here yet, but we'll get to that in a bit. And just for completeness, let's put a loop, classic C++ for loop. And if you're wondering how this works, the compiler actually inserts some code here behind the scenes to do the lookup for the virtual method to call, depending on the type at runtime. And I'm not really a fan of runtime evaluation, so let's see what we can do. The factory pattern has a static create function and a string discriminant is used here to choose which one to create. One of the first rules of performance is that you don't use strings anywhere in the code, unless you positively, definitely have to. If you're writing a spell or grammar checker, you might need strings, but even then I'd probably think you'd be using a try data structure, as opposed to raw strings everywhere. So generally try to use a hash to encode your strings, and then your storage and lookups are just a number compare away. In this case, we only want to distinguish between options and stock prices. So let's use the scoped enum approach. Thinking about this, the stock price and an option price are really not the same. Stocks have very different characteristics to prices. But we've got this price class which is the base class that we're inheriting from, so we kind of have to use it. The factory pattern discriminator only knows how to create optional stock prices with the default parameters. It doesn't really know how to pass in different arguments based on the type. Usually this leads to the builder or fluent pattern that's often used in C# and Java, especially with dependency injection. That's quite popular there. So let me digress a little bit and show you the builder style. This is a nice style, but we've lost the factory aspect of this implementation again. And there's no obvious way to get this back. Let's think about this a bit more. What we can also do at the same time is get rid of this unique pointer. This will reduce the overhead on cache misses, because now the vector contains a contiguous array of prices, where each one is one after the other. I like this fluent style builder pattern, but it does give us a problem here, as we now have concrete objects of price and option price and stock price, and not pointers to the instances. so we can't put these into a vector. Adding some extra parameters, adding some default parameters onto the create method don't seem to help either. It just gives a very messy interface. Let's use modern C++'s power by first using a variant type. This is like a type-safe discriminated union and enables us to remove the inheritance hierarchy completely. Note that also the default constructors were only there because of the factory function didn't know about the specific constructor arguments. So we can mark those as deleted too. To pass variable arguments, we're going to start using variadic templates, using the ellipses notation here. Our create method now returns something of the type t, which is either an option or a stock type, and takes a varied number of args and passes them into the correct constructor. Not bad, but we can do a little better. If we use the enable if t, this tests whether the template argument t is indeed constructible using the args given, and if not, it fails fast at compile time. The factory function is smaller and evaluated at compile time, but how do you do the loop iteration? We no longer have a pointer to the base class. We now have another design pattern to use, the visitor. This is a very elegant pattern, I find, but annoyingly convoluted to implement in any language without compile time evaluation. And I find it in the normal case that it results in the compiler doing a lot of vtable lookups, making it really, really slow. We can do significantly better if we use if const expert. While we're at it, let's also fix the code for the for loop to make it into a nice for each loop with an auto-ref. And then we can use the visit method that's in C++17 with a lambda. And we can test for the type and execute the specific code based on this const expert. Using this approach, this even allows us to call a specific method per class, making it even more powerful still. I hope you enjoyed this first video in a series on modern implementation of design patterns. If you want to keep following the series, be sure to like and subscribe, and contact me on LinkedIn for consultancy or follow me on Twitter for further videos. Thanks very much, and I'm Ronnie Chowdhury.